Hi, this is FIFO, and as the last video of this series of the classic wrapper, we're going to go and do an exercise together. We're going through the repository and we're going to create an optional wrapper with a counter that is going to count how many transactions have occurred with even or odd number. So it's a very fun and simple exercise just to exemplify how one could go and experiment with the code base and these examples and look at implementations that are already in there to borrow inspiration and to learn further on how to build on Soroban. So let's get started. So for this demo, I'll go through the same repository and I'll do everything by improvising. I didn't prepare anything beforehand, and the idea here is that I demonstrate how I often get existing code base and play around and look at other implementations that are already in there to borrow inspiration, to find problems with what I'm doing, and to simply go through trial and error until I get my use cases implemented. And I think it's a good exercise for those that are starting to learn from it. So for this one, we're going to use the optional approach. If you don't know what I'm talking about, go back in the series and watch the other videos. So we're going with the optional approach for the classic wrapper, which is a very simple one. We're going to leverage the existing implementation of it, and we're going to create a new contract that is a custom rule or a custom behavior for this asset. And this custom behavior is very simple. We are just going to add a counter contract that is going to check how many transactions we've done with an odd number amount or an even number amount. So let's get into it. As I'm starting, I'll first navigate to the contracts folder. Where am I right now? I am at the root of the project, and I'll go to the contracts folder, cd contracts. Oh, sorry, I'm still not there. cd contracts. All right. So I'll initialize by using the CLI, so Stellar Contract Init and the name. So let's make a counter contract. There you go. So I don't like this initial structure, so I'll change it a little bit to be like the other ones. I like to keep the source right at the beginning, since for my counter project, I'll just have one contract. So I'll just go ahead and let me just check. Yeah, I just have these two. Sorry, I'll just move this one out to the counter. I'll leave the other things in there and I'll remove this. And I'll customize this cargo terminal in the same way as the other ones because I am using a workspace here. So this workspace includes all contracts within the contracts folder. So I'll just have a look at how I've been doing with the other ones, like the campaign. And since I'm doing a similar one as the campaign, I'll just borrow from its cargo terminal because I'm going to use the same dependencies, same standard traits. So I'll just import everything from my counter. There we go. I'll just change the name of my package because that's the name that the file will be created with. So for this, we'll go with a counter contract. And that's it. I'm not changing anything else. And we are going to use the standard traits. So let's go ahead and open the lib, the entry point. Something I usually like to do is to remove responsibility from the entry point. I like to have a contract file that has the main contract and separate further functionality into other contracts. Here, I think just the contract file will be fine. So create a contract file, contract.rs. I'll remove all of these from my lib file, which is the entry point, and I'll add the module for contracts. There you go. Awesome. So let's go into contract, and for now I'll remove the tests. We won't be covering tests in this one. I know, what a shame, right? It's just to go faster. Let me just close this one, and at the end we're going to test everything directly in the testnet. So all right, what am I missing here? There you go, just saved. Now I'm just using the no standard to remove the standard libraries. We don't want to compile a lot of things that we're not using in the contract. We want it to be lightweight. And we are just importing the module for contract. So in the contract, we are going to build our contract. So what I suggest is get another one that was already built, put it side by side and start looking at it as a reference. So let me just go ahead, look at it here and see, okay, what do we need to do? First, we need to ensure that if we are building a contract, we need to specify the macro and the contract name. So I'll do that. And I'll import the contract here from the SDK. And for the name of this contract, we'll call it counter contract. There you go. We need to implement this contract. So how are we going to do this? Do we need to initialize or not? I'm thinking here that perhaps not, because we just want to keep track of how many transactions happened. And the first time that we try to access this value, since we don't have anything stored, we can just assume it is 0 because we didn't have any transactions yet. So let's not implement an initialize. And with that in mind, we probably don't need any custom functionalities for this contract. We just need to implement the interface. So how do we implement the interface? We need this macro contract input when we are adding the implementation of a contract, and we need to import it from the SDK as well. And now we need to add the implementation. So we're going to, oh, there you go, Copilot going crazy. Let's go. We are implementing not this one, we're implementing the asset controller trait. There you go. And we are importing the asset controller trait from the standard traits. If you recall, and if you look in here, it's an interface that only defines that we're going to have a review transfer function that receives the same parameters as a normal transfer. So, all right, that's what we're gonna do. Let me just, sorry, I'll just hide this a little bit to the side and let me go back. All right, so let's make our implementation. We're implementing the asset controller trait for the counter contract. There you go. It already implemented. I didn't like this. Let me just remove this over here. It's just copying from the other references. That's the problem with Copilot. Sometimes it goes crazy and you don't want that. So it's already prepared for me, the implementation of the review transfer. And then that's everything we need in here. We need a review transfer that is going to receive the from, the to, and the amount. That's because that's what our wrapper is going to pass. In reality, all we need here is the amount, because we're going to make a counter. So we can just ignore the other two parameters. So for the amount, what we need to do is we need to first read from the storage if we have a value stored. I mean, actually, let's take a step back, because we don't want to read both values from storage. We can store those separately or together in one struct, but let's say we are going to store them separately. And that first we need to check if it is an odd value. So we get amount, and we'll say that if amount mod 2 equal to 0, it's even. And there goes Copilot. I didn't expect it, but let's say if it is even, we want to store this value. And we want to make sure that we are tracking how many even amounts were transacted. So let's read from storage our value. But how do we read from storage? First thing you notice is that whenever you're handling Soroban, it runs in the host environment. And the way we can access things from the host environment is the env variable. We always receive the env variable as the first parameter as a way of injecting into our contract information and functionality from the environment. So we can check what is the current ledger block, what is the timestamp of the network, and things like that. So here we're going to use this env variable to access the storage. So we're going to do env dot storage. Whoops, sorry. And why it's not auto completing? I think I didn't import it. Let me just save. Whenever I save, you see that Rust Analyzer will update everything in the states. So let me just go ahead and import the env as well from the SDK. And let me also import the other things that we are using here, like the addresses. All right. And now we are going to check with storage. Okay, env.storage. And here we have different types of storage. So for this one, we're going with instance. You could go with temporary or persistent. We're not going to the detail of the differences between those ones and when to apply. But for this use case, we'll go with the instance. So it lives as long as the instance of the contract lives, and it can be extended or recovered along with the instance. So we go with instance and we'll get a value. But how do we identify the value that we are reading? So we can have two values. We can have the odd value and the even value. So for these, we generally create data keys. So instead of using the storage directly here, let's organize it a little bit. Let me create a separate file to handle the data. So I'll create the data or storage, however you want to call it. I'll call it storage and I'll include it in the lib. So mod storage. So now I have a module for storage. It's just a new file, doesn't have anything. Right, people, how do I interact with storages? Well, you can have a look at the other contracts if you want to borrow inspiration. Like for example, the campaign, we have a few things and I'll borrow from those as I normally do. So we'll get a few macros to derive clones and the contract type, to define this as a contract type. And this is generally something you always use when managing data. You want to have an identifier for the data that you store in the storage, right? And this is a way of naming your data. So for this, we generally use enum and we name the keys separately. So in this case, we'll have two. We'll have one for odd number and one for even number, and they will store a U64. Arbitrary. I'm just adding this as a comment, as a good practice to whenever I look at my data key, I know right away what kind of data they relate to. So let me go ahead and remove this. So we have two data keys. We can store data with the key of odd or with the key of even. So for those, now let's make the functions that actually read and write these values into the storage. So, and first things, if I save this, I'll get some errors because I'm not importing those. All right, so there you go. Now I'm importing it. So let's go ahead and build, and there goes Copilot. I'll make a public function because the function I'm doing right here, it's separate from my contract. So if someone runs the contract right now, there's no function write odd. This function is being created here in this module so that I use it in my contract implementation within the functions that I'm going to expose to the outside world, to people interact with my contract. So this is like an internal function to help me organize ideas and responsibility. So I'll make this write odd and I'll take this suggestion from the Copilot. So here I'll get env, and I have to get the env address because I am going to access the storage, so I need the environment. And I'm getting the number of the odd. But here let's call it a little bit different. Let's call it odd counter. So, or better, odd count. So what is the current odd count? And what we're doing here is we are from environment calling the storage, specifically the instance storage. Then we are calling the set method, which says we are putting something in the instance. And we are putting this in the data key for odd. So I want to go to the key of odd, and no matter if there's something there or not, I'm putting data in there. I'm setting that space as the odd count. So if I go back then in the future and read from that key, I'm going to get the value I just put there as the odd count. And I'm going to do the same as a read. And there you go, Copilot just helped me. And I have the read odd now, which will just receive the env. It will invoke storage instance again. This time it will call the get. So it will pass the data key for odd and it will unwrap the value. And in the end, in Rust, this is common. We don't need the return keyword. If we just remove the colon at the end, the last value is already what is being returned. So what is this unwrap? So the data, it might be there or not. It might be the first time we're accessing there, and it might be encoded depending on the kind of data that we wrote in there. So when you do the unwrap, if there's nothing in there, if the data is not there, we didn't write anything, we're probably going to get an error. So what we need to do here is, sometime it will be the first time I interact with this, and there will be no data. So what do I expect to happen if there is no data at all? So I can do unwrap, or curiously enough, it auto-completed, but I think, yeah, I didn't import the env. That's why the IntelliSense was not showing the suggestions, but there you go, unwrap or. So there you go. I'll try to unwrap. If for some reason I am unable to unwrap, I'll just set it as 0. There are other options like unwrap or default and so on, but in this case, I'll just go with unwrap or. If I can't unwrap, I'll go with 0. So that means no count. All right, so I did this for odd. Let's do the same thing for write. And I could have done just one write and one read function. I'll just go this to keep those separate, but I could use one and just pass as a parameter if I'm using the odd or the even key. But in this case, I don't have to pass the data key back to my contract. My contract can just say, hey, I'm writing an odd number. I don't know what's the data key being used for it, and this is kind of separated from the rest. This responsibility is only in this file. That's what it does. It doesn't care about business rules. It just writes and reads from the storage. All right, so let me go back to my contract. So now we know we have an amount being transacted that is even. So, there's the suggestion. I'll first create a variable, let even count, and I'm going to read even. Why am I doing that? I know that the amount is even and I want to add to the existing count. So what I'm going to do is I'm starting a variable and I'm reading from storage what is the current even value that I have stored. So I'll put that in the variable and I'll make it mutable so I can change it. And now what I'm going to do is I'll add another counts to the even, and then I need to write it back. So let's see if it's going to suggest. There you go. It will suggest to write the even number. Don't always trust Copilot. Always double check what it's doing or suggesting. It's a good way of streamlining your development, but only when you're doing things that are like no-brainers and you know already what you're doing and you just want to speed up. But that's a common way of introducing mistakes, because it can just hallucinate and think of different things than what you were intending to do. So basically, very simple. I am checking if it is even. I'm reading the current even from the storage, I'm adding one, and I'm writing the new number back to storage. And in case this is an odd number, let's add the else. Let's add the else suggestion here. Let's see if it's going to suggest. Oh, there you go. Let's see. Yeah, it sounds correct. It's basically starting a variable for the odd count, reading again, same thing, adding the count to 1 and writing again. So that's what the reveal transfer need to do. No more than that. It's just going to reveal. Did I add those? I think I did import. So let me just go ahead and import those functions from my crate. There you go. And you can see they were imported from the other file. So read even, read odd, write even, write odd. Awesome. If I save right now, the errors go away. There you go. Now these are unused. So what we can do with this is just set this, the underscore, to indicate they are intentionally unused, because the interface expects that, but we're not going to use. So we're just ignoring those and we're just focusing on the amount. So the reveal transfer is ready, but how can we know it worked? Well, once we're out of once we have done already transactions and we added to this count, we need to check the count. So actually we're going to need a specific interface for this project. So let's create, as we did before, an interface for this project. How do we usually do? Usually we just create this public trait with some name that identifies it. So in this case, let's say public trait counter trait. It's good to identify the type of variable that you're creating. And there you go. Oops. I don't know what is showing there, but no, that's not what I'm trying to create here. You see, there you go, Copilot going wrong. I'm going to add a function to check the count. So let's say I want to have a function to read how many odd numbers I had and how many even numbers I had. So let's create a read, or better, let me put get even count. There you go. It receives the env, and the env is always passed by default whenever the contract is being invoked. So you always have to define the first variable as the env, and it's going to return a U64, which is the type of variable that I use to store this value. And now I'm going to add another one for getting the odd number. Count. Oh, there you go. So I have these two, but they need to be implemented. I just defined the interface. So now down below, I'll add another contract implementation. There you go, in which I will implement the counter trait. There you go. Thanks, Copilot. I'm implementing the counter trait for the counter contract. So you can see I have different implementations, one of the standard and another one which is completely custom. And I am exposing two functions, one for getting the even count, which basically just reads the even value from storage and returns. And again, I don't need the return keyword. I can just remove the column at the end and the last value will automatically be returned. And the same thing for the odd count. So there we go. We have our contract. It seems pretty straightforward. It seems to have all we need. So let's test it. I'll go ahead, since I'm within the contracts folder, and run the CLI for Stellar Contract build. Oh yeah, sorry, I need to be within one of the TOML files, so I'll go through the, what is the name of the repository? Sorry, the folder, counter. So again, let me run the Stellar Contract build. It's going to build all of the contracts. Oh, there you go, it's building the contract right now, the counter. It was built. Where is it? So as this is a workspace, these are going to go to one central directory. Here at the root, you find this target. Target will have this was32 and no. And here under release, you see all the compiled WASM files. And here is our counter WASM. There is our contract. So I can already send that to the blockchain and start implementing and integrating with it. So let's do that. So let's go now to the playground, right? Let me close these, closing everything. And let me demonstrate how I usually go around playing with those in testnet, and I use Stellar Plus for that as a easy way to streamline this in repurpose code. So I'll go back to the root, and I'll go to the playground, which I mentioned before. In the playground, we have this classic asset wrapper project. In this playground, it's an old project with some automations in this make file, and that's what I'm going to do right now. And I encourage you to play around and create your own contracts and do the same process to test your implementations. So here, I'll add a variable for this contract, which is the counter contract ID, but I don't have a contract ID yet. Let's see. I don't have a contract ID because I didn't deploy this contract. So we'll use the make file and the automations to do that. I'll just create the variables for now, and I'll tell the name of the file. So wasm counter file, and the name of my file, there you go, it's counter wasm. Let me just double check. If I go again, I can see it's counter wasm. In the variables, I already have the directory where all the contracts are going to be built to. So I just need to inform the name of the file so I can add a comment to access that file. So I have the other ones in here. Let me add the comment in here. I want to be able to deploy the counter, and I want to be able to generate the bindings for this. So let's start one step at a time. Let's make a deploy. I'll copy this and I'll create another comment. This will be deploy counter. If you hear some noise, it's my dog chewing a bone behind me. Sorry about that. So here I'm just running the script that is under this directory, and this script can be seen here if you want to have a look. It's under deploy, upload, and deploy. And basically what it does is it initiates an account uploads the WASM file to the testnet and deploys a new instance, and then outputs the WASM hash and the contract ID. So that's what we want to do, but for our newly created counter contract. So I'll go ahead here and select the WASM counter file, and I don't need to change anything else. The directory is the same, the script, everything is the same. I just want to have a comment for my deploy counter. And as a good practice, please add some documentation or add the command to the help here. So I'll go ahead and add one more line, and this command will be the deploy counter, and it deploys the counter contract and logs both contract ID and WASM hash. There we go. Let me see if my make file was successfully updated. Make h. There you go, and I have the deploy counter now. Awesome. So let me go ahead and run this command. All right, so my script is being invoked. It should start by initializing an account. We should be, oh, there you go, there's the output. Started the script, initialize, loading the contract WASM, deploying the contract, and we should see the contract ID in a moment. There you go. And now we can use this contract ID over here, and there you go. Now we have a contract ID. Why do I want this contract ID? I want to generate the TypeScript bindings, and in order for the command for TypeScript bindings to work, I need to access a contract ID in testnet. So that's why I wanted a contract ID here. So let's add a command to generate the bindings. We have other ones in here. We can just clone one of these. So let me clone the campaign one. And the campaign one now will be the counter one. And the only difference is we don't need to change the CLI, we don't need to change the command itself, just the ID of the contract. So the counter contract ID. The bindings are the same, and the output folder, that's important because we don't want to mix different bindings that we are generating for different contracts. We want them to go to separate folders. So I'll add counter there. And again, it's important to add some information about this command. So I'll add this here. This is the help that gets outputted whenever we will run make help. So we'll change one of those as the generate bind counter, and it generates the bind for the counter contract and outputs to the bindings directory. Yes, perfect. The same, the rest is the same. Awesome. So let me just check make h. There is it. So let's run this and get the bindings. So why am I doing that? Oh, there you go. Whenever you run this on Windows, I'm on Windows right now, you're going to get some errors, but no matter what, it's going to get generated. Sorry, my dog just wants to leave just a moment. All right, I'm back. So it gets generated no matter what. If you come here within the playground and see .binds, you find the counter in here. So what are the bindings? This is a programmatically generated code that provides TypeScript interfaces to use the asset. Now, personally, I'm not a big fan of using this directly. I prefer to take a different approach, and that's a personal preference. I just borrow some things from these types, and things that I do it right now this way because I didn't automate those in Stellar Plus yet, but I'm planning on doing it in the future. So for now, I'm going to generate my own interface for this contract and borrow some things from the bindings. So I'll create a contracts folder for my counter within the contracts. And I'll start by creating first the constants. The constants is a file in which I put two things. If you look at another one as a reference, I generally put some, actually three things. The path to the file. So I'll do the same thing here. It adds the path to the file, but in this case it's called counter.wasm. I'll add the methods that this contract will have, and that is to map the enum in a TypeScript format or naming to the actual Rust naming of the functions. So for now, let me just keep it empty, and I'll generate and I'll add the spec This is the encoded XDR for the contract interface. So I'll just empty the array because I'll get those from the bindings. Oh, and it's important to add the import from Stellar Plus for the spec, which comes originally from the Stellar SDK. So if you're just starting, don't worry, you can get that as you're moving forward and playing more with the contracts. For now, let's just get those from the bindings. So I'll close this one and look into the bindings. The bindings that were generated, they provide a lot of information about the contract. You can see each one of the methods and how these variables are going to be translated once you are invoking those. When you see these specific types, they're generally either a number or a big int. So let's first get the important ones, which is which methods we want our clients to access. First is the review transfer, which is a method that we don't want to expose here. We don't want to use it, and we don't expect it to be invoked directly. Right now it can, because we didn't put any sort of blocks to it. We didn't request any special authentication, but we don't want to use it in our client. We just want the other contract to invoke the review transfer. So we move forward and see the other two ones, which is get even count. So let's add a method for that, get even count, and it needs to translate to the same way the function is named in the contract. So it needs to be in snake case. There we go, get even count. And we'll do the same thing for the odd, get odd count. Let me see, yeah, correct. And now let's get the spec, and the spec is down below here. So get the strings, and I'll fill in my spec. And there you go, this is my constant file. I don't need anything else for my constants. So now I like to generally create a types file just to put my Typescript types for my functions, just as a way of keeping things organized. So I have two functions that can be invoked. So even though this is sometimes redundant or unnecessary, I like to do it as an exercise to keep organizing my code. So I'll create a I'll export a type called get even count payload, and the payload is what I need to pass to my function to make an invocation. But in both cases, the payload is empty. I'm not passing any attributes. I can compare this with the review transfer, in which I can see that's the actual interface. So I'm not passing anything, so that's the payload. And it's the same thing for the get odd count. Now in terms of response, I'll have export type get even count response. It's a U64, and we already have these types in here, and in Stellar Plus you can just import those, but in essence this is just a big int. So I'll do the same thing for the get odd, and you can see here in the Typescript, in the bindings, that this is the return. It's going to return, in this case, a promise of an assemble transaction, but the important piece is that the return value at the end is going to be, it's going to resolve to a U64, which is a big int. So that's what I'm doing here. That's what I'm adding here. And that's all I needed from the bindings. So let's make my class, let's make my interface. I wanna interact with this contract. So I'll go ahead, create my index.ts file, and I added a comma by mistake. Let me take it out. There we go. So let's create a class to interact with this contract. I'll start by creating an export class. It's going to be called the counter contract, and it's going to extend the contract engine. So this is a special class that we have in Stellar Plus that provides you with a lot of contract related capabilities. So whenever you extend this class, you already have built-in functions to deploy contracts, deploy WASM hash, to get the contract ID, to make invocations, to just read values from the blockchain. So it's a good kickstart for anyone that is implementing for the first time or getting to know better how to build on Soroban. So I strongly recommend you start with that. And as you grow your knowledge and expertise, if you want to create something very personalized, go for it. Like, it's just a quick way of starting and keeping things fast. So I'll go ahead and use this one. So first I'll have a constructor because there are some specific values that this class expects. So I'll just get the arguments as the contract engine constructor args. There they are. And I will support them into the mother class. There you go. What am I missing here? Oh yeah, just misspelled it. There you go. Now I have my class, I initialized it. Our contract doesn't need an initializer, so we have two ways we can interact with this contract. We can get the event count, or we can get the odd count. So I'll add two public functions. Both are async because they're going to invoke the blockchain and resolve to the value at the end. Get, there you go, Copilot, get even count. It will resolve to have a promise, and it will resolve to a U64. But I really like to keep my structure typed, even though it's redundant at the beginning. It's a way of keeping things separated, because sometimes you're going to reference those across multiple places in your application. Sometimes you need to change those over time, so it's easier to have like a centralized payload type that you can just update the rest of application as a consequence. So here I will use my get even count payload. There you go, and that's my sorry, not payload, response. That's what I'm going to get. And let's go to the implementation. And the implementation, we are going to use one of the functionalities that is part of the contract engine. So we are going to return await, and we are going to call this read from contract. So read from contract is a special function because it is going to build the transaction, simulate it with the RPC, but it's not going to actually execute the transaction. And that's because this is a transaction that does not change state in the blockchain. So we don't need to pay to actually carry this transaction. If nothing is changing in the blockchain, we can just simulate those by looking at the current state of the blockchain and get the output which is correct without having to pay any fees. So that's what the read from contract provides you, a way of simulating and getting the output without having to run your transaction. It's much faster and it's much cheaper because you don't run any actual transaction. So this is only reserved for when you don't want to change state in the blockchain. So I'll use it. I'll use the read from contract, and it's going to get some arguments. So in this case, what I need is basically, let me see. All right, so what we're going to add to this one, it's a few arguments that it takes, right? So let me add the object. So first, it's got to know what is the method that it's invoking. So in this case, I'll add the method argument. And for this, we're going to use the enum we created before. So I'm importing methods from the ./constants, which is the file we have alongside us. And that will have the list of methods. So we want to do the get even count. There you go. And we need to provide the method args, which in this case, it's an empty array. It's an empty object because there is no parameter to pass. So I generally use these and strictly put these as a way for people to come and know and get Typescript to verify things. So, all right. What else do we need to add in here? We need some information about how to build this transaction. Since this is a simulated transaction, we don't actually need an account with a lot of money, or we don't actually need to sign for a transaction. We just need dummy data. And in this repository, we provide you with an easy way of doing that, which is to spread this function called read tx invocation through a transaction invocation. And this is a quick way of providing this data for a read transaction with dummy data. Right, and something we need to do right now is that because of the way it outputs the result, we're going to just force this as an unknown and as get the even count response, something I need to change on Stellar Plus, but for now that should be enough to ensure that we can invoke the even count. it will simulate the transaction and provide me with the output without having to run the actual transaction. A very simple way of making this interface. So now let's duplicate that and make another one for our get odd. So let me just go ahead here, select the even, and substitute by odd. I just have to import this response. I am calling the method get odd count. I'm adding the payload as well, and there we go. We have our interface. So we're ready to start using this and integrating this contract in our application. So let's build some tests. Let's go ahead to the tests folder and create a new file for counter.integration.test.ts. And let's look at the other ones to borrow inspiration and see what we need to do in our test. So first, I really like to break the test into the different phases of the test. So whenever you're looking at that or at the result, you can know exactly where things are failing and what you need to adjust in your test. So that's why I like to do it in this way. I'll start by creating the describe for the test. Let's create it like this. And let's name first the whole test that we are wrapping in this describe. So it's a end-to-end test. Let me see how I did in the other ones. Yeah, let me just use the same standard and to end optional classic wrapper test with counter. There we go. And now let's write these tests. Okay, so within that we are going to need a few variables. So I'll start by just creating these variables without actually instantiating them, just so that I can pass them to the inner scopes of the other tests. And here I suggest you have a look on how Jest controls the order of execution between describes and it functions, so that you understand how this state is propagating forward through the whole test. So I'll start by creating an SAC, which is basically a handler for classic assets. And since this is a classic asset dependent use case, we're going to use an SAC handler to create and manage this asset. We are going to create the wrapper, which is going to be an optional classic wrapper. Awesome. We are also going to create our counter contract. So for this, I'll import our newly created counter class. Oops, there we go. We also are going to need an admin account, so someone that controls this asset. And for this, we're going to use this default account handler from Stellar Plus, which basically generates a new key pair and handles the signatures for us and removes all of the heavy lifting for these quick testing use cases. And lastly, we need a network configuration for which network we're using. And in this case, it's also an object from Stellar Plus, and we are going to use testnet. So, all right, this is what we need. So let's create, yeah, there you go, Copilot. Let's do this manually. For all async, I'm going to create a before all function with what needs to be done before any of the tests run. So let's instantiate these variables. And Copilot is correcting here. We are going first to select the network. The network is going to be testnet, and this is being imported from Stellar Plus. So we're getting the configuration for testnet right away. And let's see what we're doing in the other ones. Okay, I'm going to load the files, the WASM files of the compiled contracts. So in this case, we are going to use the optional wrapper. So I'll get the same one I used in the other tests. You can go ahead and copy those with no shame. And when loading the file, we need the path. If you remember correctly, we added the path in the constant file. So I'll add here was path. We have a bunch of those. I want the optional wrapper path. So I'll load it, but I would like to identify it differently so I know it's the optional. So it's optional was path. Let me just copy it here. And let me do the same thing for the counter. const counter was equal to wait load. There you go. But I want also to load the file. So select wasm path and select the one from the counter. There you go. But I also am going to change the import name so I can identify as the counter wasm path. There we go. Awesome, perfect. So I have both files loaded. I have them loaded into a buffer, and with this buffer, I'll be able to deploy them to the testnet. So let's move forward. And what else did we do? Okay, we already had the testnet configuration. Let's create the admin account. Okay, so admin account, same thing as in here. We'll instantiate the admin account as a new default account handler, but there's no await. There's nothing like this. Actually, we are going to get the admin. If you're using this repository, we have this helper function to facilitate. It provides you with a singleton of an admin account. So first time you import it and use the get admin, it's going to instantiate and initialize this admin account. Next time you use it, it will just provide you with the object. So it's a good way to facilitate having a standard admin account throughout your use case. So we're getting the admin account, and now we're going to initialize our token. So SAC, it's a new SAC handler. We're going to provide the main configuration. So it needs a network configuration. That's what I'm passing on here. It needs an asset code. So yeah, let's go with people. You can name whatever you would like. And we are going to set what is the issuer account. And here we are passing the admin, which is the default account handler. That means that whenever we use the SAC, its inner features will have the handler for the account of the issuer. So they can enable issue capabilities to sign as the issuer and authorize certain transactions. So moving forward, now it's time to instantiate the contracts classes. We're not running any transactions. We are just instantiating the classes here locally. So let's create one for the wrapper. There you go. The optional, the compiler already helped me creating a new optional classic wrapper. I'm providing the same network config, so also for testnet. I'm providing the contract parameters, and that's what I'm going to use to deploy this contract. So since we have the WASM file, we are passing the WASM file as a buffer. Optionally, you could start with the WASM hash if you'd like. So both are valid ways. If you already have the WASM hash, you can start with that instead of the file. But here, since we have the file, let's go with it. And the spec. So you remember we prepared that spec. So I'll import again in the same way, optional wrapper, and I'll rename for something that I can better identify. Where is it? Spec. It's optional spec. And let me add it here. That's all I need to instantiate a new wrapper. And let's do the same thing for the counter. And it will probably be the same, but we also need to import the spec. So import the spec and rename it in the same way. All right, as counter spec. All right, so we have both contracts. We instantiated everything. Our admin account was initialized. So let's start running actual transactions. Let's start configuring this use case. So the first thing we need to do, and we are going to start a new block now, and that's within, let me see, let me just get out of the before all. And now we're going to create a new describe block because it's another section within the entire use case. So in this section, we are going to run the pre-configuration. Pre-configuration, we are basically preparing the asset. So let's do this. Let's add, let me see how I named it before the contract setup. So let's use the same naming. I like that. Let's standardize it. Before the contract setup, we are going to set up the asset. So there you go. It should wrap the asset in an SAC Stellar Asset contract. So let's do that. It's already providing to me. So await expect. We are doing an async test, and basically what we're saying is we are going to invoke the function that's not the name, SAC dot wrap and deploy. So SAC handlers have this functionality already in there to allow you to quickly wrap and deploy an asset. So these are not the parameters. Let me do it from scratch. So we're going to wrap and deploy, and we need to provide a transaction invocation. So the parameters on how this transaction needs to be executed. So who's paying for the fees, how it's going to be signed. So for this, we are going to provide the admin transaction invocation. And I believe we do have that in the utils. You just need to, in the utils, you just need to import it. So I'll go ahead and import it. It's a function. So you just provide this in here. It will use the same admin that we set before. So once this resolves, we expect this to resolve, and we expect it to be defined resolves to be defined, and that's it. Once it finishes, we expect this execution of the transaction to run correctly, and once that's done, automatically the SAC the SAC class, the instance, will update its contract ID. So we have a contract ID for the classic asset. So let's do another expect, because I expect that after this runs, we should see the SAC Soroban token handler get contract ID. I expect the contract ID to be set and to match exactly. And there you go. We have an util from the Stellar Plus, contract ID rejects. So it's the specific rejects of how a contract ID looks in Stellar. And basically we are checking the string that is returned as contract ID and make sure that it looks like a contract ID. So I'll run that. Before we move forward, let's first test this in isolation and see if it works. Oh wait, what did I do wrong here? Contract, I added one more. I think that's it. And there you go. Actually, yeah, I was missing some curly brackets. So let me go ahead and update the makefile so we can run this test. So we have these two. Let's add a third one, and this third one is going to be the test counter end-to-end, and we'll update the counter file as the test that's going to be run. And in the same way as we did before, let's add the help to explain what this command is. So we have the counter, and it describes that this runs for the optional classic wrapper with the counter contract. All right, let me see. Let me go ahead and check it here. Make help. There we go. We do have it. So let's give it a try. Let's see if our first step's running so far. Let's execute it. It should run in testnet. So we expect at least for the asset to be wrapped in an SAC. So let's wait for it. There you go. It executed. We can see we just have two blocks. The end-to-end test. Within it, we have the describe for before the contract setup. And in this section, it should wrap the asset contract, and it should provide a contract ID. We have our asset, so let's prepare our contracts. All right, let's go back. Let's close this in here so we have more space. Let's look in there. So we wrap the contract. What do we normally do after that? We have another block. We have the during setup. So let's create this block over here. So here's closing the it, here's closing the describe. Yeah, let's create another block. So during setup, what do we do during setup? In this case, we are going to upload both contracts, and we are going to deploy both contracts and initialize the contracts, but not the counter. The counter doesn't have an initialize. So let's copy from the other tests up until the initialize. Let's copy until here, and let's repurpose these tests. So First, we don't have a campaign contract, we have a counter contract. And we are going to upload the WASM. So let me select it, counter. It has an upload WASM feature function, and that's because it extends contract engine. So if I check, we have all these capabilities from contract engine that allow me to manage the contract. For now, we just need a few ones, so let's go with this. This one is going to upload the WASM using the admin transaction invocation. So the admin is paying for the transaction and all the fees. Once this resolves, we check if the counter has a WASM hash set, and it should match the WASM hash regex in the same way. After we upload the counter contract, we do the same thing with our wrapper. So this is a standard, in the same way we did with the other tests. And now, once we have both codes in the blockchain and we have the WASM hash for where this code lives, we need to deploy new instances. And these new instances will get their own unique IDs, so we can start making invocations to these contracts. So first we should deploy a new instance of the asset controller, which in this case, the asset controller is played by the counter contract. So I'll use our counter contract to deploy, also using the same admin to pay for the fees. We expect it to resolve and run correctly. And in the end, we need to check and ensure that the counter has a contract ID that matches the ID regex. So once we do that, the next step is to deploy a new instance of the wrapper. Very default, we want an optional wrapper to be deployed and used in combination with our counter. And if we go down below, we have this initialize campaign, which we copied from the other test. But we don't have to initialize our counter. We don't have an initialize function. So I'm just going to delete that. The wrapper, on the other hand, needs to be initialized because the wrapper needs a reference to who is the counter contract, who is this asset controller that it's using. So we are going to invoke the wrapper initialize. We are using the admin invocation. So for this, we spread it in the arguments. And then we provide the arguments that are necessary for the initialization. That's how this interface this client has been built. So we provide the admin by getting the public key of our admin account. We provide the asset. In this case, we get from the SAC our contract ID, and that's the contract ID of the SAC contract. And then we get the asset controller, which in this case is the counter. So let's provide a contract ID, and that's it. We expect it to run and be resolved. So after that, what is next? Well, after that, the contracts are initialized. So let's add the next block, which is what should happen once the contracts are initialized. So for this, let's create another block within the whole use case. All right, and this is once the contracts are initialized. So we are also going to create two users. So within this block, I will create two variables to live in this scope. So since I'm creating this, since I'm declaring these variables right now, these are going to live only within this scope, the scope of this describe and onwards. So I'm going to make the setup of both users as an inner block. And in this setup phase, we are going to initiate those accounts. So let me just borrow from the other tests. We have this before all, and before all of this block is executed and its sub-blocks, we are going to instantiate both users as default account handlers in the same way we do with our admin. So the keys are managed automatically, the signatures are managed automatically, we don't have to worry about that. And we invoke friendbot to initialize these accounts and send 10,000 lumens. So once this is finished, we start running the tests for these two users. So once the users are initialized, we start with the first test, which is to create the trust lines. So we can just borrow this as it is because we want these users to have their trust lines. And here something is different. So let me walk you through what this is doing. So in this test, users should be able to create their own trust lines. So we're invoking the SAC, the Stellar Asset Contract, with the classic handler. So we're doing this through a classic Stellar transaction, and we're using this add trust line transaction. So it's a transaction that is going to have a trust line operation that will set a trust line for the user A to engage with our asset. And here we're using this simple transaction invocation, which is also a helper function to help you streamline your tests, which basically create this invocation data for the user A. So this transaction is being invoked by user A. He's the one sending the transaction Stellar. This user is the one paying for the fees. So there's no admin involved in this step. And we are doing that for both users. So both users are creating their own trust lines, and we expect that to resolve and go successfully. Once that's done, then we can add another test for the user to mint some units. Sorry, for the admin to mint some units for these users. So let's go ahead and do that. I'll just again borrow from it. And let me make sure it's correct. Okay, yeah. So what I'm doing is basically I'm invoking the asset class, the SAC for the asset, but this time with the Soroban token handler. This means that I am invoking the SAC contract and not the classic asset directly. And I'm invoking the mint functionality to send user A 1,000 tokens. And here, since I'm using it through the smart contract, the standard is to use big int to manage amounts. And in this case, the big int includes all of the decimals. So for a classic asset, this means 7 decimals. So 1,000 tokens, 1, 3, and 7 decimals. 1, 2, 3, 4, 5, 6, 7 decimals. There you go. So I'm sending 1,000 tokens to user A. And this is being sent by the admin. That's why I use the admin transaction invocation. And I do the same thing for user B. Once this is finished, I again invoke the classic, the SAC, this time through classic, through Horizon, to check the balance of user A. And I expect it to resolve to be 1,000 tokens. So that's what I'm doing here. So I'm checking for user A and I'm checking for user B as well. All right. So after we did all of that, we finally come to the block in which we are going to use the contract. Because up until this point, we did a lot of things. We created a classic asset, we wrapped it in a contract, we created a wrapper contract, we created a counter contract, we deployed those, we uploaded the WASMs, we deployed those contracts, got the instances, we initialized those, we initialized accounts, initialized the trust lines, and everything. Now we have users with tokens ready to transact. So what we expect to see right now is, as one user sends money to the other user, we are going to keep track of how many of those transactions are ending in odd or in even numbers. So let's make one transaction and verify that the counter is going up. And then let's make a few more transactions and make sure that the count continues to go up. So after the users are ready, let's just add a bunch. Oh, there you go. Should be able to call the count. No, that's just wrong. That should be able to call the wrapper contract to perform transfers and track the odd and even transactions. So that's what we're going to test in this one. And to finalize our experiment, I'm going to run a bunch of transactions and test the count at the end of each one. So let's start with, there you go, await, expect, because we're going to await this execution to finish. We are going to execute this through the wrapper. So we're going to send the transfer through the wrapper. So we are going to send to user B from user A some amounts of tokens. So we're going to send from user A dot, wait, that's, why is it not? Oh yeah, I just put it outside of the wrong scope. So let me close this. This should be within the upper scope. So let me go here. User A dot get public key. So we are making a transfer from user A to user B, and this is using the client that is already in the repository, you can use the same clients to invoke the wrapper to user B, an amount. Now, how many tokens? Let's say we want to send, let's say 100. And in this case, remember the decimals. So we are sending 0.000 tokens. So to finish it, we are going to add the invocation from the perspective of user A, because it's user A that is making this transfer. So close it here. Yes, this needs to be a big int. So let me just add a big int. Let me just organize this here. And we need this to resolve. Sorry, what am I missing here? Amount. Oh yeah, there's another one. Yeah, resolves to be defined. There you go. So we're making a transfer from user A to user B. This transfer is of 100 stroops, or 100 of the smallest decimal, and this should increase the even number. So let's, right after that, await expect. There you go. No, wait, it's making another transfer. I don't want that. I want to await expect, invoke the counter to check the even count. And the even count, we expect it to resolves to extract equal. No, that's not what we want. We want to resolve to equal. Yes, so this time we'll do the following. Since begins cause a lot of problem in jest, we want to convert this, the output in the end, to a string. So I'm going to store this in a variable. I'll wait, const odd even count. Even count to await counter get even count. So I'll wait for it to come in there, and then I will say that the even count should be string. I'll convert it to string to compare to the other number, and that's just because the jest and begins won't go well along. And since I am not invoking it right in here, I don't need the await and I don't need the resolves because it's already in there. It's going to be synchronous. So this should work. Now, before we run this, since it takes a while, let me just add a bunch more of these transactions. Let's fast forward a little bit. All right, so let's get back. How many transactions are we doing here? We're starting by making one transaction from user A to user B. User A is paying for the transaction. We expect the even counter to go up by 1. Then we do another transaction from A to B, again, another even number, and we check if the counter is again increased. So we expect the counter to go to 2. Then we do another transaction, but this time from user B to user A, to show that no matter the user, the numbers are being tracked globally. So we do another even transaction from B to A with 80 units, and we check again for the counter, expecting it to go to 3. Right after that, we check the odd count, which so far haven't changed, so we expect it to be 0. After that, we do another transfer from B to A for an odd number, 1 unit, and we expect the odd count to go up to 1. So that's the first one that adds to odd. Then again, we do another transfer from A to B, another even number, and then we again check both to make sure that odd didn't change and even went up to 4. And that should be enough to test the whole use case. Let me just go check if I'm closing things correctly. I think so. Let me just save to organize. All right, the moment of truth. Let's see if these tests are working. Let me go ahead, all my end-to-end tests. Let's wait for it once again. While it's running, I'll just go grab some water. I'll be right back. there you go. And luckily, I didn't do anything wrong apparently, and the tests were successful. So let's just revise how the blocks look. So we start our main block for the, let me just go back then, the end-to-end optional classic wrapper test with counter. So that's the main block and everything is encompassed in it. So it starts the block for before the contracts, and it runs the setup for the classic asset. So you're wrapping the classic asset into an SAC. Once that's done, we start the actual setup for our use case, which is to upload the counter contract, upload the classic wrapper contract, then we deploy a new instance for each one, the asset controller, which in this case is the counter contract, and the classic wrapper. Then we initialize the wrapper. The counter doesn't need to be initialized because we don't have an initialize function and we're not keeping track of those. Then once the contracts are initialized, we start both users account. Sorry, let me just double check, because I think the name of it, oh, there it is, interesting. I think I added it at the end of the block or something. It's interesting that this is appearing up here because it should be able within. Oh yeah, it's right afterward. Okay, so I got what happened. I ended up leaving this outside of the user setup, and it threw me out for a moment because I would expect this to happen after the setup of the users, and it does. And actually it doesn't, because it's in the outer block, and that's a mistake I did here. But luckily it didn't fail because of the way we are doing it. Okay, so it threw me off a little bit because I would expect this to run afterward, but by lucky in the order that things happened, it didn't break the workflow. It's just that instead of keeping this within this block, I ended up putting it when the block was already closed. So let me just fix it here, because I would expect this to happen in here. And now it will be correctly after the users create the trust line. So I'll run it back once again and have the correct order. So I'll just jump into the future once everything is done. All right, there you go. Now it ran, and then now it's looking as I expected. So let me have a look and tell you what is going on here. So again, we start with the end-to-end. We do a prior to the setup step in which we wrap the classic asset. Then we do the whole setup for the contracts, uploading both WAS into the networks, then deploying new instance of both contracts, initializing the wrapper only. And then once the contracts are initialized, we start this block, which sets up both users. The users create their trust lines, and then the admin is able to mint units through the SAC to the user, and this reflects in the classic balance. And then at the end, after the users are ready, we run the transactions. All of those transactions check for the odd numbers, the even numbers, and they match. Now, if you want to look further into this, try to extend these capabilities, maybe track the count for specific accounts. This could be a nice challenge, like how many odd or even number of transactions have this user receive against the other user. That's a simple thing to change in the contract and could be a nice challenge for you to explore different ways of accessing storage and play around with these interfaces. So feel free to download this repository, break it, play with it. I hope you like it, and if you have any questions, just shoot a message to me, and I hope to see you in the next videos. So see you, bye bye.